For this first video in your Section 5 notes, I just want to talk about graphing a few special sort of shapes. The first one is 4 times cosine of theta. You can see already that it's a circle kind of shooting out towards the right side. Just want to talk about where that comes from. So our function is defined as, I shouldn't say function, but our equation is defined as 4 times cosine of the angle will equal, and this really means r, it means the distance that we're going to go. And if we just kind of check this, if I were to plug a 0 in for theta, cosine of 0 is 1. 1 times 4 is, this result would be 4, so my r value is 4. I just want to show you that that is true. Now if I were to just move this up a little bit, let's go to a more familiar angle, maybe 30 degrees. Cosine of 30 is, let's see, what is cosine? It's square root of 3 over 2. Okay, square root of 3 over 2. Multiplied by 4 gets me 2 root 3 basically. And then 2 root 3, if I simplify that, gets me 3.46. So if I were to angle at 30 degrees and go a total distance of 3.46, you can see that, let's see, this is 1, 2, 3, almost 3.5. It gets me to this part of the circle. And so anything that, any of the angle measures that are kind of in between there, it still works out. I'm just going to work with more of the familiar ones. If I plug 45 degrees in, I get root 2 over 2 for cosine of 45, root 2 over 2. Multiplied by 4, I get 2 root 2, which if I put that into my calculator gets me 2.83. So if I go at an angle of 45 degrees, so I'm shooting out this way, but I only go up 1, 2, almost to 3 there, you can see that that's also on the circle. And so I'm just going to kind of move around here just a little bit, and you can see that it always, no matter what angle it is now, so now kind of interesting, let's go back to 120. 120 degrees is actually shooting out more like this, but notice that my r value when I do this is negative. So even though I'm thinking of shooting this way, it's going backwards, and it gives me the bottom part of the circle. Okay, so I keep going around. If I get to 180, okay, cosine of 180 is negative 1 times 4 is negative 4, as you can see right there. But now I am, so I'd be going 180 degrees, but I'm going backwards by 4. That gets me one complete circle, so if I were to go a full 360 degrees, you just see that it repeats itself one more time. So just wanted to show you that, show you how that goes together. You should be, by the time we're done, you should be familiar with what happens with 4 times cosine or 4 times sine, or even eventually 4 times secant or 4 times cosecant. And so we'll just be thinking about that. Do you kind of know what's going on with those kind of basic ideas by the time we're wrapping up Section 5? Another type of equation that I want you to be familiar with is something called Rose curves. And so I'm going to change some numbers here a second before I show you anything. Let's look at what happens. So this is a typical way that we would define a rose petal or a rose curve. Okay, it's going to have a number in front. That's my a value, and then it's going to be maybe cosine or sine times theta. But now there might be a number in there. So what we were just looking at was 4 times cosine of theta in the previous example. It's a circle that kind of goes towards the right side. So we kind of know what that 4 does. It might give us the size of the circle or maybe the petals. I want you to notice what's going to happen when I change the b value. So we're going to look for some patterns. Okay, there's when b is 2, 3, 4, 5, 6, 7, 8. And what you're noticing is for the even ones, if we were to count them, so here b is 2, we have 4 petals. Here it's 4, there's actually 8 petals. Here it's 6, there's 12 petals. But when it's an odd value, I just have 5, or 3, or you could say 1. Okay? We could also talk about what happens with the a value. It's just controlling the length of the petals. And then I also want you to think a little bit about symmetry here. For symmetry, what I mean is, like, we could reflect across the y-axis and this would get us the exact same thing. I could reflect across the x-axis, it would get me the exact same thing, or I could even rotate it and I would have the exact same picture. That's when B is even. But when B is odd, you can see that now I could still rotate, I could still reflect across the x-axis, but I could not reflect across the y-axis and have the exact same shape pop up. Okay, so that's what happens when we have cosine there. If I have sine, it works very much the same way. Okay, A still controls the length, B still controls petals the same sort of way, but the symmetry will look a little different. Here for symmetry, it has all the exact same characteristics when B is even, both types of reflection and rotation. But if B is odd, I can still rotate it, but now I can reflect across the y-axis, not the x-axis. That's the big change when we think about sine or cosine. When B is odd, there's only one type of reflection symmetry for each, and they are different. So I want to kind of summarize that all for you. So I'm going to hide the shape, and I'm just going to put up some different captions here. And I think you have a spot in your notes to kind of copy some of this down. So I'd suggest that you pause this, copy some things down, and in another 5 seconds I'm going to end this video.